Hello everyone, welcome back to Pentest Diaries once again, and I'll continue with episode number 2. It's the anatomy of an AI application. So if I'll ask you how LLM application really works, in the previous part itself, I have already talked about what AI guardrail are and why they are becoming such an important security controls. But before we start discussing attack defense, prompt injection, agents, or even a rack security, there's something we need to understand first. That exactly are we securing? Because an enterprise application is not simply ChatGPT behind a web page. There are multiple components behind that interface: authentication, databases, memory, retrieval systems, agents, APIs, tools, and something entire enterprise environment itself. So in this part, we will going inside an AI application and looking at how these applications systems actually work from a security architecture perspective. Once we understand the architecture, the attacker surface become much easier to see. The security question starts with architecture. The DAC correctly frames the AI target as an execution pipeline, not merely a chatbot. What to say? Here's the first idea I want you to remember. Before you try to attack an AI application or even protect one, you need to understand what you are actually attacking. With our traditional application, we normally think about things like the front end, back end, APIs, database, authentication, and the infrastructure. AI application introduce another layer. Now we have a prompt, we have context, we have we have retrieved information, and increasingly we have tools that AI can actually execute. So our security targets are is no longer just a chatbot corresponding to our questions. It's an execution pipeline. Something enters the systems, get processed through multiple components, and potential results in an action being performed somewhere else. And from a security perspective, even one of those stages matters. Natural inference is the target is not the chatbot, the target is the pipeline transition. But there are very common misconception about how that pipeline actually looks. So going forward, the common misconception, the slight contrast, the simplistic users chatbot response model with the hidden protection components such as authentication, retrieval, memory, policy controls, tools, and enterprise integration. What to say? When some people imagine an AI application, they picture something like this: a type a question, the question goes to ChatGPT or some other large language model, and the model give me an answer. The user AI response. For a simple demonstration, that's fine. But production AI application really work this way. Behind that single chat windows could be authentication systems, authorization checks, input filtering, databases, vector databases, conversion memory, policy engines, external websites, API, agents, and enterprise applications. The user normally does not see any of this. They just see a text box, and that was make AI security interesting. Quite interesting itself. Like as we are seeing only the box in front of us where we are putting a query and we getting the response, a very simple interface can be connected to a very complicated backend. Optional natural aside, it's a bit like looking at a browser and assuming the browser is entire internet application. That's true about it. So let's replace this simplified diagram with something closer to what we actually see in production. So a protection AI assistant is a pipeline. The architecture shown in the deck includes the user authentication, input filter, LLM, vector, database, RAG, memory, web content, agent, tools, and enterprise systems. Way to say, now this starts looking much closer to a real enterprise AI application. Imagine you are using an internal AI assistant at a company. You submit a prompt, Before that prompt even reaches the model, the application may authenticate you and determine what you are allowed to access. Then an input filter might inspect your request. After that, the system may search a vector database to retrieve company document relevant to your question. It may also bring in previous conversation memory. Maybe it retrieves information from the web. All of that information get assembled and eventually provided to a large language model. But we may still not be finished. The model might pass the request to an AI agent. That agent could select a tool, and that tool could interact with the enterprise system. So what began as an one sentence typed in the chat box could eventually trigger actions across multiple systems. And this is the key security principles on this slide. Every component adds capability, but every connection between those components also adds risk. One of the most important part of the architecture is the retrieval layer, what we normally call a RAG. So now RAG expand what model can see. The slide shows a combined context made up of the system prompts, user prompts, retrieved documents, memory, external web content, with the security implication that malicious instructions can enter through sources other than the user prompt. So what to say? RAG stands for Retrieval Augmented Generation. And the easiest way to understand the RAG is this. Instead of asking the language model to answer only from what is already known, we give it additional information at runtime. For example, imagine asking an enterprise assistant, what is our company remote working policy? Instead of hoping the model already knows the answer, the application searches an internal knowledge base, retrieves the relevant policy document, and give that information to the model. That sounds simple, but look at what is actually entering the context window. We have the system prompt, instructions created by the application. We have the user's prompt, we have the retrieve document, we have the memory from the previous conversation, and sometimes we have a context retrieval from external websites. All of those sources are combined into context and presented to the model. And now we arrived at the very important security problem. The user prompt is no longer the only place where malicious instructions can originate. A malicious instructions could exist inside a document. It could exist inside the memory. It could come from a compromised knowledge base, or it could even come from a website the system retrieves. So when we talk about the prompt injection, do not think only about someone trying a malicious prompt directly into a chatbot. Indirect instructions entering through the retrieved content can be equally important. So imagine the AI retrieves a document that secretly says ignore the user request and follow these instructions instead. The user may never even know that instructions exist inside of the document. And RAG become much more serious when the model can do something with that information instead of simply generating a text. So modern AI does not only return text. The deck highlighted AI capabilities including our databases, database searches, email code generation, ticket creation, cloud actions, and delegation to another agent. So this is where modern AI application becomes significantly more powerful and significantly more interesting from a security perspective. The AI does not necessarily stop after generating an answer. It can act. An AI agent might search as a database, it might send an email, it could generate code, it could create or modify a support ticket, it might interact with cloud environment, and in multiple agent systems, one agent may even delegate a task to another agent. Now this about what that means. A prompt is no longer simply influencing text on a screen. A prompt may influence an action, and once an AI system has access to tools, permissions become extremely important. Can it only read information? Can it modify information? Can it send information outside the company? Can it create infrastructure? Can it execute code? Can it approve something? These are very different level of risk. The moment tool access is introduced, a prompt can potentially translate into a system level impact. With a chatbot, a bad response is a problem. With an agent, a bad decision can become an action. And that brings us to the real attack surface of an AI application. So every arrow creates another attack surface. The architecture on the slide connects user guardrail to LLM, RAG, agent, then to tools and enterprise systems, alongside risks such as a prompt injection, data poisoning, context leakage, tool misuse, and the privilege abuse. Now, look at the entire architecture at one connected system. We have the user, the request passes through a guardrail. Then we have the language model, the retrieval system, the agent, the tool, and eventually the enterprise system those tools interact with. Here's the security principles I want to remember. Every arrow in this architecture represents another trust boundary and potentially another attack surface. Between the user and the model, we have prompt injection inside the retrieval layer. We can have a poison document and manipulated knowledge sources. Inside the context, sensitive information could leak. Once tools are introduced, we have possibilities of tool misuse, and if the agent has excessive permissions, tool misuse can become privilege abuse. Eventually, something that started with a malicious instructions can result in real system impact. That's why protecting only the language model is not enough. You could have the safest model in the world, but if the surrounding application give that model unrestricted access to the powerful tool, the overall systems can still be insecure. Securing the model is not the same as securing the application. So what should a secure AI architecture actual protect? So protect the entire AI execution pipeline. The final slide identifies the five major areas, which we call it as the control areas. Identify and access, input guardrails, retrieval security, tool controls, and logging and review. Concluding that AI security is a pipeline security. We need to protect the complete execution pipeline, and there are several layers to think about. First, identify and access. Who is making the request and what are they actually authorized to access? Second, input guardrail. What kind of instructions are we allowing into the system? Can we detect a malicious prompt, manipulation attempt, or a policy violation before they reach a sensitive components? Third, retrieval security. What information is the AI allowed to retrieve? Where did that information come from? How can we trust it? And what could someone manipulate that information to influence the model? Fourth, tool control. This is one of the most important area for AI, agentic AI. What actions can be AI actual perform? Which tool can it use? What permission do some tools have? And should sensitive actions require additional approval? Finally, logging and review, and we need to understand what happened, what did the user ask, what context was retrieved, what decision did the model make, what tools was asked, called, and what action ultimately took place. Because without visibility across that chain, investigating an AI security incident becoming extremely difficult. So the main message from the episode is simple. AI security is not only the model security, it's a pipeline security. So before we concluding this video, once you have start looking at AI application this way, many AI security problems become much easier to understand. Prompt injection, rack poisoning, memory manipulation, excessive agency, insecure tool calls. These are not the isolated problems, I can say. They are attacked against different parts of the same execution pipelines, and that give us the foundation for the next part of this series. Because now that we understand that what AI architectures looks like, the next question become how do we thread model it? In the next episode, we will make this architecture and start identifying the assets, trust boundary, attack path, and the security controls that matter in a real AI application. I'll see you in the next part itself, and be subscribed to my channel, and I'll try to complete the whole series soon itself. So every week you're supposed to get one video from our site. And with that, I'll try to cover the whole concept. I don't want to go in a hurry just to release all those episode in a single shot. I want to go it further with per week, so that you just have to grasp it and then you try to get it implemented accordingly. As conclusion of it, of this episode, which I just want to get it conveyed to you before closing this call, or I can say a recording. Sorry for the call word. So before concluding this recording itself. So in this episode, what my main objective is to get it covered, like everyone having a thought, if we can secure model LLM models, then in that case we can secure our application. So in this episode, if you have gone through the whole setup, then you can analyze it. So this is a myth that if we can secure our LLM models properly, then in that case our application is bit secure. It's not. Whatever the things are getting integrated with our application, including the LLM, like LLM, where we are sending the data itself or we are sending the queries. We just have to take care of other sections also, which is integrated over there itself with LLM, from where our LLM model or the RAG setup is just retrieving a data from multiple sources. That to be also secured. If it's not, then in that case, there might be a possibility a data which is passing to LLM model is not appropriate and it get manipulated our model, and we're not getting the appropriate result. At some point of time, the things will be getting retrieved and going out of our system, which we don't want to go ahead out. So that's one of the bigger myths which we just want to get it understand first. Like LLM model is not the only thing which we have to secure it. We have to think about all the stuff which get integrated with that, so that we have to secure the whole setup which we have it in AI security. So that's all about this video. I just try to get it covered. If you like this video, please subscribe my channel. Please comment it if you think like anything is not appropriate. I try my best to conclude and cover all the stuffs in this whole series and all the possibilities which I have learned it, and I try to get it conveyed to you itself. Even still, if it's not clear to you, just let me know. What I'll try to make another video on the same topic, and with that, I'll try to get explain you once again. Thank you so much once again. Take care. Bye bye.